Mr. Willson H. Hunter. He is the NASA Senior Scientific Representative in Australia. Today, he's going to give us a valuable information about his responsibilities and his activities in NASA Australia. Too many people, I believe, these facilities of NASA in Australia has been very important in tracking the spacecraft and satellites all around the Earth. I believe that Mr. Willson Hunter will today giving us the valuable information about the space program or the space activities in Australia. Good morning, Mr. Hunter.
Good morning.
Firstly, I would like to ask you about your responsibilities and your activities in NASA in Australia.
My principal role in Australia is to provide liaison between NASA headquarters in Washington and the Australian government who manage our programs in Australia in space tracking and data systems. And I work from the NASA office and headquarters of space tracking and data systems. We have, as shown in the first slide, many facilities in Australia, and the slide that I'd like to show you now illustrates a typical deep space complex in Australia. We have a complex like this in Madrid, Spain, and in California. So if we could see that first slide, we might show you two of our typical tracking station antennas. The large one is 210 feet in diameter, or 64 meters. The smallest one is 85 feet in diameter. And
I remember you have one in the Goldstone, also 210.
Goldstone and Madrid have similar ones. Now the next slide shows typical jobs that we have to do in space that are done from Australia and from these other stations as well. We have to track application satellites that go, and scientific satellites that go around the Earth, sounding rockets, aircraft, things that go into deep space as probes, and those things which go to the moon and to the planets. A new system that we're developing is shown on the next slide, and that's called the Tracking and Data Relay Satellite. This large satellite has the capability of tracking in space some 40 different satellites and finding out exactly where they are and taking all of the data from them. And as shown in the next slide, the data is relayed from the satellite to the tracking and data satellite, and from there to the ground at New Mexico, White Sands, New Mexico, so that there will be one of these large tracking satellites over the Pacific and one over the Atlantic, and they will virtually cover the entire Earth, so that the shuttle, the space shuttle orbiter, as shown in the center of the picture, and all other low satellites will be tracked, and the data will be relayed from these satellites.
So this is the new system of tracking.
Yes. Now this system will be in operation in 1981.
I see.
Now the next slide shows one of the things that we're quite excited about, and this is the space shuttle. It shows it here in an artist view of it being launched from Kennedy Space Center in Florida. And that space shuttle orbiter will be the principal vehicle used in the future for launching all of our spacecraft after, say, early 1980. The next slide shows the developing things. That you can see in part here the base of a very much larger device which will orbit materials to be used in space for constructing very large structures.
How different between the payload between the
55,000 pounds of cargo into space and bring about 35,000 pounds back from space. The advanced transportation system that we're considering would take maybe 250,000 pounds into space, so it would be very much useful in building things. Now I'd like to talk a little bit about some of our deep space things. Now the next slide shows the lander that we put on Mars in the Viking program. Now you may all be familiar with this lander. We have 2 of these on the surface of Mars that are working now after several years. The next slide shows a proposed concept of a roving vehicle. Now you see it here in going down into a ditch on Mars, and it would have ability to pick up material and so on, and that has wheels on it. There are many other concepts, but the next slide shows an even more imaginative proposal. This is a very lightweight airplane that would be parachuted down to the lower altitudes around Mars and would fly in the air density is about the same as Earth at 100,000 feet. And this airplane would be powered by rocket fuel and would have cameras aboard to photograph the terrain.
Will they be manned or?
No,
or
unmanned devices. Another project we have in deep space is one that is coming to fruition very quickly, and the next slide shows the project manager, Charles Hall, at NASA's Ames Research Center, with the probe that will go into Venus. The next slide shows how this will operate. Venus is shown in the center, and on the right is the Venus orbiter, one of the 2 spacecraft that will relay data back to Earth. And on the left, you see the probe, which was in the previous picture, with 4 small objects being launched from it to impact on the surface of Venus, as shown in the next slide. Here you see one of the probes on the right of the screen in the center, landed on the surface of Venus and measuring data in the atmosphere on the way down and at the surface. The surface there is so hot that it would melt lead, so that it's an extremely hard job to make something work in Venus.
Will this probe survive the soaring heat of the atmosphere of the Venus?
We expect that it will, and it will do that in about the first week in December of this year. So we're getting ready now to do this very difficult job of tracking the probes on their way down to the surface, getting the atmospheric data back from them, and having the orbiter relay all of this back to Earth. Now another job that we're looking forward to is a solar polar mission shown on the next slide. Here you see spacecraft launched from Earth, one of those inner circles on the left, around Jupiter, which acts as a slingshot and throws the probes back over the sun. The next slide shows the complicated trajectory of the spacecraft coming around Jupiter, which is used as the turning point, and then going into a circular orbit over the sun, as shown in this next slide, which shows one spacecraft going down around the sun and the other one coming up around the sun, both very close to the sun, and measuring the solar magnetic field, which is a very great puzzle to us because it appears to fluctuate, and these devices continuing around the sun and around Jupiter will help us measure that solar magnetic field.
So this will be the first mission that spacecraft will orbit from polar to polar of the sun.
We've never been near the pole of the sun until Jupiter 10 recently went over, Pioneer 10 went over the top of the sun, or near the top of the sun, and told us some things that were quite exciting, and now we want to do this in a proper way. The next slide shows the Jupiter, this is the spacecraft that will be used to go around the sun. But the next slide shows the Jupiter probe and orbiter. You see the spacecraft in the center going by Jupiter and near one of the large moons of Jupiter. And on the left is the parachuted probe which will go into the atmosphere. I think the next slide will show this more clearly. You see the probe which has a heat shield on it initially, and then it will come down by parachute and land on the surface of Jupiter, because Jupiter is a very unusual planet, almost like the Sun,
Yes.
but maybe frozen hydrogen. And we want to know much more about its atmosphere, which rotates in 9 hours instead of our 24 hours.
I see.
And it's very much larger and denser than the Earth's atmosphere. The next slide will show another future thing. This is a possible probe onto one of the large moons of Saturn,
Titan, isn't it?
Titan, which has an atmosphere almost like that of Earth. And it's a planet, it's a little planetary-like body, which is of great interest to us in the solar system. Now, another thing that we would hope to do in future would be to rendezvous with a comet. And the next slide shows the kind of a spacecraft with electric rockets. On the left of the screen are the electric rockets. And the next slide shows a better view of that, with the spacecraft in the center and the big solar panels which will power it with the electric rockets in it, actually rendezvousing with a comet. You see the comet tail in the background. Such a device might accelerate continuously at a very low rate, but for a long time, and reach the speed of a comet and rendezvous with it. And then we would discharge packages from that center spacecraft to land on the comet and measure it. So that's an exciting thing we're talking about. The next slide shows a large space telescope that we would hope to launch with the shuttle in the next few years. And it would greatly amplify the amount of the universe that we could see in all frequencies, ultraviolet, infrared, and the optical frequencies.
Is this will be launched by the space shuttle?
Space shuttle orbiter, yes, would take it up. Now, scientists are interested in intelligence in outer space, and the next slide shows one proposal of many antennas on Earth grouped together to form virtually a much larger telescope, larger than we could build by itself. And the next slide shows another arrangement in which the telescopes are built in craters on the far side of the moon. You see 3 of them here in craters, like the big one we have at Puerto Rico, at the Arecibo station. These would be large radio telescopes grouped together, acting as one big one, on the far side of the moon, away from Earth, so that Earth radio frequencies will not disturb it.
Will there be any problems about since will be the far side, and it sometimes will heated by the sun?
I think no problem there. I think no problem, but we would listen for intelligence from space, if there is any, and we think there should be some, and we would continuously monitor this, and I think it's an exciting project. Whether we ever get the money to do this is another question, but it's a thing the scientists are thinking very much about. Now, when we're working in space, one of the things we need to do is to build big things in space. We think this is coming in the future. The next slide shows a new machine that is being developed to extrude beams. This slide shows the machine with a triangular beam being extruded from it. Now, in space, where things are weightless, you could just extrude this beam without any support. The next slide shows the shuttle with such a device. The shuttle orbiter is in the bottom, and there's a vertical member coming up in the center of the screen, and that the 3 beams have been built. The machine is at the top, extruding a new beam. Now, that kind of thing might be used as the foundation for what is shown on the next slide, and that is the solar power station. A thing of this sort, if we could afford to build it, and I think one day we might, would generate 10 billion watts of power and beam this power down to Earth for use on Earth. In other words, this would replace power generating stations on Earth.
It will convert into the microwave, is that right?
Microwave, and then beamed to Earth, received in antennas, and converted to usable electricity. And that's a very exciting concept. People think about future things in space. Now, of course, these are not approved projects, but it's nice to think about them. The next slide shows what Dr. Gerard O'Neill of Princeton has proposed to us. it's a large, these are two large space habitats ringed by factories to process materials in space. And the next slide shows the inside of one of these where maybe 10,000 people could live. It would rotate so that there would be gravity. Trees, lakes, houses, just like we have here, could be built in such an environment as a what we would call a space settlement.
How long it will be?
Oh, that's in some distance in the future, but it's the technology to do those things must be thought about and must be worked on.
Yes.
Now, we're doing very many sensible, immediate things which are applicable to helping us on Earth, and I think we ought to look at the next slide to see Landsat-C, the latest of the Landsats which has been put up. This is one of those, of two satellites now up, which is observing Earth resources. And the next picture is one taken by that. You see the Gulf of Thailand on the left and the Ban Satahip on the
right
point there. And the next slide shows the Bangkok Plain. Now there's an arrow in that you may not be able to see down at the bottom, but the flooded Bangkok Plain is the black area there. The next slide is a close-up of this, and this is what the computer can do with this kind of illustrations. A close-up. The next slide is an even tighter close-up. You see the clongs, and so where the arrow is there, where they intersect. And the next slide is a further enlargement, and you can begin to see the actual plot size of farms and paddies and so on, or paddy fields there, so that we can use this to sort of indicate which crops are planted and how many acres are planted in these crops. And people doing resources studies can then use this sort of information for forestry, for the growth of cities, for crop control, pest detection of pest, destruction of plants, and so on. Now there's another spacecraft that we have up called the Heat Capacity Mapping Mission, and that's shown in the next slide. It was launched sometime earlier this year, and the next slide shows the kind of a picture that it sends back. It measures the temperatures of things, and this is a picture of part of the United States. And the dark blue is the coldest and the white is the hottest. And in another part of this same picture you could see the Gulf Stream off the coast of the eastern seaboard of the United States. And this is going to be a device which will help us to detect groundwater, thermal energy sources, and so on the Earth. Then there's a new one that we've launched as of June of this year. The next slide shows the CSAT. And here you see the device. The top of it is not, the solar cells are hard to see there, but the large white thing is an antenna 7 feet by 35 feet long, which is a synthetic aperture radar. It's an imaging radar which can give you very fine resolution pictures of the oceans and the waves and everything else. And then the other instruments will measure wind velocity and wave height. There's an altimeter there that measures the height of this above the ocean, so we can see the bumps in the ocean, and there are bumps due to gravity changes around the Earth. And it can measure wave height, velocities, depths of water, and so on to some extent. And it's going to be very useful, as the next slide shows, in servicing. Oh, that doesn't happen to show it, I'm sorry. It's off the screen there on that picture. But the CSAT is a whole new look at oceanography, and it's going to help ships navigate through ice. It's going to help the design of ships, the sighting and the operational safety control of oil exploration rigs in the ocean, and perhaps find the best routes to travel and warn ships of waves and things of this sort. And it'll give us a good look at the weather, since 70% of the Earth's surface is water, and it is a principal driving force for our weather system, that if we know more about the oceans, we can then have a better handle for what Earth's weather is going to be like, or its climate. Ocean temperatures can be measured this way, and so on. So that you can see that we have a number of very solid application programs going, and these will be expanded. They are great, like the weather satellites, they're a great benefit to man on the street. We like to think about the other far out things because they are a challenge that someday we would hope to get to do.
Thank you very much. I would like to ask Mr. Hunter another question. You haven't mentioned about the other fields that the NASA's venture into it, such as the to find the new energy to substitute the oil and gas is going to be.
Well, we work closely with the Department of Energy. In the United States, the Department of Energy has the responsibility from Congress for all forms of energy used on Earth. Now, if we have energy we need in space, that is our responsibility. But when it is to be used on Earth, we have to work with them, and they provide us money. And we are trying to get the cost of solar cells down to a very low value. We're working on electric propulsion for automobiles. We've developed for them some very large windmills to generate electricity, and we have 3 of these in being.
How about thermal energy?
Well, thermal energy, we're working on gas magnetohydrodynamic generators, which don't require cooling water and are they're almost like jet engines in a sense. And thermal energy, we're using concepts for getting energy out of the ocean by the temperature difference between the low water and the high water. And this is a concept that we're considering. We're working very heavily on synthetic fuels for aircraft and the conversion of coal to aircraft fuels. And we have one program that you may think is impossible, but we plan within 10 years to be able to have airplanes flying which will have 50% less fuel use per seat mile. In other words, we'll cut the fuel consumption of aircraft by 50% by better engines, better combustions, lighter structures, better aerodynamics, better wings, cleaner airplanes, and so on. And it's quite a program, and it is working exceedingly well. We'll make the goal very easily.
So NASA has been working and will achieve the goals of such as the try to have the quiet engine.
Yes.
And
the quiet engine is with us now.
And so on. Besides these activities, I think NASA also has converted the technologies, space technology to use it to use in the daily living, such as in the hospital, that sort of thing. Can you mention a few things?
Well, we have done a great deal in our planetary explorations. We have found out how to enhance pictures. And we now are able to take X-ray pictures which appear to have no information on them and to find blockages in blood vessels and things of this sort. We are able to screen blood samples very quickly for genes, the genetic structure. We have developed lightweight braces for legs of cripples and so on. We have meals for the elderly derived from the Skylab system, which have a shelf life of 2 years. And very simply heating these, we can get a wide variety of meals out of boxes, which can be warmed up very simply by an elderly person. And there are so many things that have been done in the field of medicine and nutrition that it's almost hard to explain all of these things. But NASA, well, one of the things at our Lewis Research Center, we're using a cyclotron to make a neutron beam to do radiation therapy on cancer patients that is safer than using cobalt to radiate cancers. So we're actually bringing patients into our laboratories under clinical control to do things for them. So NASA is very heavily involved in the direct transfer itself into the medical fields, nutritional fields, house building, automobile design, you name it, we're in it.
Thank you very much, Mr. Hunter. On behalf of the viewer, I would like to express my appreciation, and may I thank you so much for your time to present on this program, and I hope that the information you have given to the viewer, I think will do a very useful things for our viewer, and I hope that if you happen to come to Thailand again, will you please come to appear to our viewer again.
It's been my pleasure to appear here, and I would certainly welcome your invitation. If I return again, I would like to see you and perhaps talk more about space. Thank you very much.